So I hope you all are good and doing well. Nano? Everyone is okay? Then very good morning, everyone. So let's get started with good energy, positivity, and with hope that we will be learning a lot in today's session. Done. So I will be basically discussing wave optics thing. So I will also discuss a bit of theory, whatever is required to know in that. So that will be taking 15 to 20 minutes, and then we will be again doing questions. But before that, let me go through some match and column questions of ray optics that we finished almost yesterday. So some questions I just want to discuss, just a recap of things it will be happening. For these questions, I'm not going to give you much of time. I will be discussing and just that will jog your memory, right? So what the question is here, you can see in column 1, different curvatures are made, 2 mirror and 2 lenses are there. And in column 2, nature of images is written, right? So we have to match column 1 to column 2. So first case may, I will be just keep on asking and you have to answer in your head only. What will be the answers then? So the first thing is what? First is a concave mirror, right? In option A, you can see this is a concave mirror. So in concave mirror, we already know that what sort of images it can form. It can form real image. It can form virtual image also when the object is in between focus and pole. Done. So it can form virtual image also. Magnified image, yes. Image at infinity, yes, when object is kept at the focal length. So A can match to all the options. So correct option for A will be P, Q, R, S and all. Done. Now let's come to the second thing. Second is what? Second is a convex mirror. Again, this is a convex mirror. And for convex mirror, we know that it always forms what sort of image? Virtual image. Real image it can't form. Magnified image also it doesn't form, and it doesn't form image at infinity. Then if object is at infinity, it forms image at focus, and if object is anywhere else other than that, then image get formed at what? Pole, between focus and pole. Then and that image used to be virtual, erect, and also diminished. Then so correct option for B should be what? For this, it was P, Q, R, S, all. And for B, it will be what? Q. Only Q, right? For C, C is a convex lens, right? So for convex lens, what we have studied, again for convex lens, real image can be formed. Virtual image also forms in the case of simple microscope, you must have seen. Like if object is kept between focus and pole, then image formed is virtual, erect, and magnified. Then so for convex lens also, all the options will be correct. That is your P, Q, R, S. Then so these three things are quite obvious. Now come to the second last one. Can anyone suggest me what will be the correct option for D? D will act as what kind of lens? This is a lens, not a mirror, because it's not silvered, right? So this is simply a media bounded between two curved surfaces. So my question is it a convex lens or concave lens overall? Yes, anyone? Just tell me, is it a concave lens or convex lens? How you will get to know which type of lens is it? Simply write the lens maker's formula. Okay? Yes. Yes, Kesu. Correct. So simply write the lens maker's formula. Mu lens minus 1 by 1. Kyuki it is kept in air. So 1, 1. This will always be positive because if nothing is given, it means mu lens is greater than mu media. So this is always positive. Now come to this. 1 by R1 minus 1 by R2. If focal length is coming as a positive, it will be convex lens, and if it is coming negative, it will be concave lens. Done. So if I'm allowing light to fall on it, this will taken as R1 and this will taken as R2. Done. So which one is more curved, R1 or R2? Which one is more curved, R1 or R2?
R1.
R1. So clearly looking at the diagram, you can see R1 is more curved. So if R1 is more curved, what will happen? Its radius of curvature will be what? Less. Done. and its radius will be more. So R1 is less than R2. So if R1 is less than R2, this is going to be positive. So it will act as a convex lens. If it is acting as a convex lens, all the 4 options will be correct for it. Done. So this was the match column. Now again, there is one more match column, and here I'm just giving you 1 minute to read the question. Just read the question, what you have to do. Just try to get sense of what you have to do in this question. Okay. Done. So you all must have gone through the question. Now, what is this? Like in option A, it is given that mu1 is less than mu2. So if mu1 is less than mu2, then which diagram can be true? Then how we will get to know that? We have to just deal with the curvature here. Let's say if you are taking a convex lens like this, then this is a convex lens, and suppose what is happening, a ray of light is falling on this surface, on surface 1 I'm telling. So if we have to see if light will bend towards the normal or away from the normal, we will simply check if refractive index is what. Done. So if it is mu1 and if it is mu2, and if mu2 is greater than mu1, which generally used to be the case, so if mu2 is greater than mu1, light will bend towards the normal after refraction. Done. So light is going to bend towards the normal. Now we need to draw the normal. So in this match the column thing, only important thing that you have to do is to draw the normal. Now what will be normal on this surface? Again, this surface is a part of certain circle. So whatever will be the center of that circle, normal will pass through that center. Done. So this is my normal. Done. And if light is bending towards the normal, it means light will go on like this through the first surface. Done. Clear? So if surface is convex surface like this, a part of a convex lens, then it will bend something like this. Now let's move on to the concave lens wala portion. If I'm taking a concave lens and focusing just on one surface, so suppose a ray of light is falling like this. Then again, what we have to do here, again, ray of light is traveling from which media to which media? It is traveling from rarer to denser. So what will happen to the ray of light? It will bend towards the normal. Again, first draw the normal. Suppose Karlo, this is center. So I am first drawing the normal, and this is my normal. Done. And suppose a light is falling here, and what will happen to this light? It will bend towards the normal. So if I'm taking a light here, and it has to bend towards the normal, so it will go on like this. Done. Samajh gaye? So this kind of with geometry you have to deal in this question. Now you tell me what will be the correct answer for option A. Only for one, let's do it. So if mu1 is less than mu2, if mu1 is less than mu2, which one is going to be true? It will bend towards the normal after refraction, and which diagram is true for that? Okay. What's your name? JV. What's your name? VK. Chalo, which option will be correct? Light is going to bend towards the normal, right? So in which case light is bending towards the normal? Just see in first case the lens is convex lens. If light bends towards the normal, it will dip down. So first will be true. First will be true now. So yes, first will be true. Now Q won't be true. Done. Again, come to the surface, come to the option R. In case of R, what is happening? It is going up like this. So it's also bending towards the normal. Just you see here, in the case of concave lens, if it is pointed upward, ray of light after refraction, if it is pointed upward, it means it is bending towards the normal. So here it is, it is directed upward, so it is bending towards the normal. Here again, it is directed downward, it is bending away from the normal. So this is not correct for one. This is correct, and this is also correct. Done. Similarly, yes, so similarly, you can check here also. Here, what is happening? Ray of light is bending. No, in case of T, it is bending away from the normal. Done. You just need to match with these two curvatures. If light is bending towards the normal, then in case of convex lens wala thing, what will happen? Light will dip down, and if light is bending towards the normal, in then case of concave lens wala curvature, what will happen? Light will seem to go up. Done. So that you have to do here. I have dealt with the concept. So that concept you have to take care of. And if media is not changing, light will not deviate. Just say you can see here, here the light is not bending at this surface. So refractive and mu2, mu1 must be equal here. Done. Similarly, you can check in other cases. If light is not bending, medias are same. Done. That you already know. And how you will check if one is greater than other? Just by looking at the geometry. Done. Is there any doubt in this thing? We will move ahead fast. You will get it matched, right? Just go through the previous year question. You will get that question there also. Or you can again browse through the video, stop at this question, and you can solve it. I have dealt with the concept. Anyone having any doubt? These questions are included so that we can discuss just basic concepts. Okay? No doubt. Okay, chalo. Again, for this, I'm giving you some 2 minutes. Do solve it and let me know. Jaldi se solve karo and let me know what will be the answer. Okay? You have to simply calculate the focal length, radius of curvature R is given. Let me know what answers you are getting. You all got the answer? Come on. What will be the correct answer for option A? What will be its focal length? This is combination of two lenses. Now, so first try calculating the focal length of one lens. That is this one. So focal length of this lens will be equal to how much? Let its refractive index be mu. It is kept in air, obviously. So focal length will be equal to how much? Mu minus 1 by R minus this. Okay. So what will be the answer? Okay. Check for B actually. Check for B once more. So, and for C also. B and C. D is correct. A is correct. Okay. Chalo, okay. So what will be the focal length here? It will be 1 by F mu minus 1 by 2 R. Sorry. This will be this into 2 by R. So focal length is going to be R by mu minus 1, 2. Mu is given now. Yeah, mu is 1.5. So let's write in that term only. So if this is 1.5, it will become 1 by 2. 1 by 2 into 2 will become 1. So 1 by f is 1 by r. So focal length of this lens is how much? R. And focal length of this lens is also what? R. So 1 by f equivalent will be how much? 1 by r plus 1 by r. That is your 2 by r. So what will be the focal length of first? R by 2. So for first, we have got for A. Done. And what for B? Now calculate the individual focal length first. So for B, individual focal length will be what? Again, calculate 1 by f. So 1 by f will be equal to how much? Mu minus 1, that is 1 by 2 into one surface has focal length as what? Infinity. And another has focal length of what? 1 by r. So this will be 1 by r. So focal length will be how much? 2r. Done. Now calculate the focal length of this combination. That will be, again, this will be positive because this is a concavo-convex lens only. So its focal length will be positive only. Now 1 by f equivalent will be equal to how much? 1 by 2r plus 1 by 2r. So how much value we are going to get? 2 by 2r. That is your 1 by r. So f equivalent for B will be how much? F equivalent for B is going to be r. That option is where, that will be minus r actually. For B, no, for B minus r nahi hoga. For B, the option will be S. Okay. So what option you are going to get for B? For B, the correct option will be S. Now for C, you can calculate. Again, this will have a focal length of minus r. It will have a focal length of minus r. So if you're going to add, you will be getting what? Minus r only. And similarly, its focal length is how much? R. Sorry, minus r nahi yaar. Ye minus 2r hai na. Done. It is also minus 2r. Again, its focal length is r and its focal length is how much? This is minus 2r. Now calculate it. Done. So I hope you all will get the answer, correct one. Chalo, which options you people are getting? For B, some of you said R. Option R won't be true for B because B is what kind of combination of two concavo-convex lens. So it will have a positive value of this. Done? Is it done? Any doubt here? Yes? Okay, let me know. Just you need to do the calculation right way. If calculation is right, this is the logic, okay? And I hope calculation is right as well. No doubt. Chalo, done hai. So now we will be dealing with wave optics. Done. And in wave optics, what we have to learn first, we need to revise a bit so that while doing question, you don't get stuck. So the very small things I will be revising up to all the important points that you need to remember. So very first thing is our YDSC setup looks something like this, the one that you can see on your screen. So if source is kept along this line, we get central maxima at this point. Why central maxima at this point? Because this is first slit, this is second slit. Distance between these two is taken generally as small d. And you can see the light getting traveled by the first one. Distance getting traveled by first light is equal to distance getting traveled by the second light. So here path difference is what? 0. So this point is termed as central maxima that you already know. Now what happens if we shift the source up and down? Initially source was here. Now we have shifted the source up by an angle theta. So our central maxima will also get shifted down by an angle theta. If we are shifting the source like this, if we are getting a source downward by an angle some phi, then our central maxima will go up by an angle phi. So this thing, these are small things, but this might come handy while you will be solving questions ahead. Okay, so that was that. Now, constructive interference we have studied. What used to be the case for constructive interference? For that, we take any general point P on the screen and we try to see that the light that is reaching at this P point from the two slits, slit 1 and slit 2, is traveling how much distance. So 1 is traveling this many distance and 2 is traveling this many distance. Which one is traveling more? 2. So there is a path difference between these two. How much extra path second light is covering? This extra path second light is covering. And if we go through the geometry, what is actually generally considered in our YDSE experiment, that this length, if this is taken as D, and distance between slates, I have already said that is taken small d. And our general assumption is that D is very, very less than capital D. These assumptions we will be taking throughout the questions if nothing is given about this D and capital D. If they look comparable according to the question, we won't be using the approximation. Otherwise, everywhere we will be using the approximation. What is the effect of this approximation? Effect of this approximation is that, just say this D is very small with respect to this capital D. It means what? It means this slit F1, let's call it F1, and there was this separation, this slit F2. So whatever line you are taking from here or here or here, all will make the same angle with the horizontal. We can assume that if D is far, far less than capital D, because these all three lights are reaching where? To the screen kept at a distance, capital D. Then, so these are very closely spaced point. If capital D is very large, then we can assume that this theta, theta, theta are same. And if that is taken, and if we go on further to the geometry, we will see that this angle is also equal to theta. Done. And from here we have got that we don't, again, geometry is important because you need to, you may be given a question where it is not as simple as this. And there actually you need to calculate delta x by applying geometry. So you must know how this angle is coming as a theta. How this is coming as a theta? We already have studied in our 9th or 10th classes that if angle between two lines is theta, then angle between their perpendiculars also used to be theta, right? So this theta is angle between this line and this horizontal line. Again, this line is perpendicular to this line and this line is perpendicular to the horizontal line. So angle between these two lines will also be theta. And from there, if we are going to consider this as triangle S1, and this is S2, and this is P, S1, S2, P, then from here we can see that delta x by D is equal to sine theta. So from there we are getting what? We are getting delta x, that is your path difference, and that used to be equal to how much? D sine theta. That is a very important thing that we are getting out of here. So delta x I will be writing as D sine theta. Now you already know that what is the condition for constructive and destructive. That I don't need to discuss. For constructive, it will be equal to n lambda. Done. And for n equal to 1, we will be getting first maxima. N equal to 2, we will be getting second maxima. For n equal to 0, we will be getting central maxima. That is this. Done. What else I need to discuss here is what is important actually. That is your, if it is said that, suppose this point P is the, this point P is what? This is suppose nth maximum. So what will be the angular position of this nth maximum? Angular position. What will be its angular position? So basically this P point is at an angle where? Theta. So for calculating the angular position, this point you will be considering as origin. This point you will be considering as origin, and from here only all theta get measured. Done. So if theta, this is theta, then angular position of P is what? Theta. And if P is nth maxima, then angular position of nth maxima will be theta. So it is asking for theta. How we will calculate that? So if it is nth maxima, D sine theta you will be considering as n lambda, and sine theta will be equal to what? N lambda by D. Again, we have to calculate theta. And if approximation is true, D is far, far less than capital D, this theta will be very small, less than 10 degree, 5 or 4 or 3, something kind of that. So in that case, we can write sine theta as theta. If angle is small, then we will be writing N lambda by D. Done. So this will be the angular position of nth maxima. So angular position of first maxima will be lambda by 2. Angular position of second maxima will be 2 lambda by 2. Now angle between two maximas will be how much? 2 lambda by d minus lambda by d. So similarly, we will be calculating. Now, what is the most important thing that we need to also discuss here is, what if this YDC experiment is not happening in air? It is happening in some other media. Suppose I have dipped this YDC experiment in oil, whose refractive index is how much? Mu. So what is going to change there? What is going to change? First, आप सबको पता होगा ना, definitely you must be knowing that. So what is going to change first? What will change for the theta? I'm asking about theta. So if I am dipping this YDC experiment in some lambda, yes. So lambda will become how much?
Lambda by mu.
हाँ, lambda by mu. ठीक है? That will become how much? Lambda by mu. Done. So this is over. Now one more important thing I want to discuss in this diagram is, suppose what is happening, upper half of the experiment setup is in air. So this upper half means S1 slit portion is in air and S2 slit portion is in oil. Now this is the case. So if certain kind of things like this is given, how we will be dealing with certain kind of things that I'm going to deal with now. So if questions is asked like how many maximas we are going to get on the screen. So how many maximas we will be getting on this screen? If you can see this screen, maxima, condition for maxima is what? Condition for maxima is d sine theta equal to n lambda. So d sine theta equal to n lambda. Maximum value of sine theta can be how much? 1. So sine theta equal to n lambda by d. And its maximum value can be how much? 1. So maximum value of n can be how much? D by lambda. Done. So maximum number of maxima that we are going to get this side is how much? D by lambda. Similarly, the same number of maxima we will be getting this side also, d by lambda. So total number of maxima like excluding central maxima will be how much? 2d by lambda. If we are going to include that central maxima, one will get added. Done. So this many central maxima we are going to get. But what if other half, one half is in air, another half is in oil? How to solve the same question in this scenario? So what will happen? For the air, how many values of n will be there? So simply in air, lambda will become lambda by lambda will become lambda. That will remain lambda because its refractive index is 1. So lambda by 1 is lambda only. For oil, what you will be doing, n will become d by lambda by v. So you will be very careful in seeing the experiment is happening in what sense and how to use certain kind of informations given. Okay? So destructive interference ka condition kya hoga? Again, d sine theta will come as same, and if that is equal to 2n plus 1 lambda by 2, that will give us dark spots. And for n equal to 0, we will be getting first minima, and for n equal to 1, we will be getting second minima in this case. Here also you can calculate the angular position of minima, how many minima you will be getting, kind of that, using the same logic that I have discussed before. Angular and linear position of fringes. Angular position I've already discussed. If d sine theta, what happened? Okay. Just give me 1 second. So for angular position, I have already discussed now how you will be calculating the angular position. So for angular position, we were writing what? If for maxima I'm talking, theta was taken as n lambda by 2. So this was the angular position. Now, when I'm saying linear position of fringes, what does it mean? For angular position, I said you will be treating this point as a center, as an origin. And for calculating linear position, this is treated as an origin. So from here, you will be calculating this distance that will give you the linear position. So in question, if it is asked that what is the linear position of nth maxima, suppose. So angular position of nth maxima is how much? N lambda by 2. Linear position of nth maxima means this y you need to answer. So how you will be calculating this y? Again, If approximation is true, I said you this angle, and this angle all were same. And this distance is very large. So if I'm going to draw S1, S2 like this is S1, this is S2, and this is a very big screen. So certain point like this. So we can treat it like a, I'm trying to say that we can treat it like an arc of a circle, whose radius is how much? Equal to d. If this distance is d, we can consider this as d also, if small d is far less than capital D. Done. So treat it as an arc. If this is treated as an arc now, or forget it, don't let us not get into complication. I'm just trying to say what you need to do here. So to calculate the linear separation, oh my God. So calculate the linear separation. Why? What you will be doing, just treat it as an arc, something kind of that, whose radius is how much? Whose radius is this, d. So if radius is given, angular position is given, we can calculate the length of that arc as what? Y is equal to what? That will be equal to d into theta. So if linear position is known, and if angular position is known, and you have to calculate the linear position, what you have to do, you have to simply multiply it with capital D, nothing else. Okay, that is done. Now fringe width, you already know the formula. Fringe width is what? Distance between two consecutive maxima. So if I calculate y value for the nth maxima, it will be equal to how much? N lambda by d into capital D. And if I calculate linear position of n plus 1th maxima, then I will be writing this. What will be the separation between these two consecutive maxima? Again, their separation will be, you will minus this from this, so you will be getting lambda d by d. So if you're going to calculate for the dark fringes also, you will be getting the same value. So fringe width is distance between two consecutive maximas or minimas, and that you will be getting as lambda d by d. Again, this distance will get influenced by in what medium you are conducting your YDSC experiment. Done? Chalo. In that case, y will get changed to, lambda will get changed to lambda by u. Chalo. Shape of fringes, this is very important. Question comes from here, and here you don't need to go much into the calculations. Actually, we need to remember two very important things. The one that is given in our NCERT YDSC experiment, these two, if we combine these two sources to a line, then we will get line like this. Then here there is just one, and here there is just two, and our screen is looking something like this. So line of S1, S2, and line of a screen, both are parallel. Done. And in that case, the shape of fringes that we are going to get will be hyperbola. Then that you must have studied. And if this separation is very large, d is very less than capital D, that hyperbola will look like straight lines. Done. So first, this is about the shape of fringes. And if second, from there questions come in 2017 or 18, somewhere I came in advance also. And there only we needed the information key. If our sources are something like this, so if we are combining these two sources, line will be this, and a screen was this. So this is perpendicular, and in that case, the shape of fringage will be concentric circles. Concentric circles. Done. So only we needed to know this information to solve that question that will be coming ahead actually. So you just need to have these two information. You can solve it also. If you're very good at mathematics, you can solve it also, like this will be the locus of all point, having the, like here, whatever light is reaching here, will all those lights will have the same angular separations or angular positions, sorry. So you can use the mathematics and see that the equation that you will be getting will belong to hyperbola, and here the equation will belong to concentric circles. Done. But we don't need to go into that deep. This information will also serve our purpose. So you need to remember that. Now this is from the SLEET. So SLEET questions generally come. What is SLEET actually? And throughout the discussion, I was talking about some path difference. What is the path difference? Is it the geometrical length difference, or is it something else? It is something else actually. So before that, what was happening? There was a YDSC experiment, something like this. And since it was happening in air, the geometrical length we take as the path length. है ना? Vicky, you didn't understand the shape of fringes. Okay, shape of fringes, I just told you that you needed two information to remember. If line joining two sources, that is slit 1 and slit 2, if that line joining is parallel to the screen, then the shape of fringes that you are going to get now will be hyperbola kind of. Done. And if line joining sources is perpendicular to the screen, then in that case the shape of fringes, just a fringe you obtain on the screen now, in YDS6 experiment, you must have shown some white bands and dark bands you obtain on the screen. So what will be the shape of those white bands that I'm talking about? That is shape of fringes, right? So if this is the case, that shape will look like hyperbola, and if this is the case, shape will look concentric circle. Okay? Are you people getting me?
Yes, ma'am.
Okay, done. Okay. Now, if you want to speak something in the class, you can raise your hand. I can unmute. Okay. Chalo. I was dealing with something else. Yes, this was the thing. So actually, when we talk about path difference, we actually talk not about the geometrical path difference. We talk about optical path difference. What is that? See, initially what was happening, our experiment was happening in air. So this was S1, and suppose this is O. And this is, suppose, a medium of refractive index, mu. Done. So what is the, throughout the media is mu. Now, what is the optical length? This is S1. Geometrical length is how much? S1. What will be the optical length? So optical length is generally mu times the geometrical length. Done. So again, you must be knowing the literal sense of what is the optical length is. Done. So just formula I'm giving you here. Done. So optical length here will become how much? It will become S1 into mu. Similarly, here geometrical length is S1O. Optical length will become how much? S1O into mu. So optical length, and in YDSC setup or elsewhere, wherever we are calculating path difference, we are actually calculating optical path difference, not geometrical path difference. Done. Since we were seeing the length difference only in media where refractive index was 1, so the difference was not coming into account. But here it will come into account. Why? Because in the path of first slide, I have inserted a media of different refractive index mu, and thickness of this media I have taken as what? T. Done. So what difference it is going to put? Just you see here, I have written everything on the screen just to avoid more hazy kind of my writing. So optical path length covered by the first slide. See, I'm writing optical path length now. Done. So it covered SS1 distance in air. So in air, optical path and geometrical length both are same because mu is 1. So SS1 I have written. Now S1O distance completely is not in air. How much of its distance is still in air? S1O minus T. So S1O minus T distance, optical length and geometrical length will be same. So I have written is like this. And for this length, optical length is how much? Mu T. So I have written here mu T. So optical path length covered by first slide will look like this. Now optical path length covered by second line, same as geometrical length because throughout it is traveling in air. SS2 plus S2O. What will be the path difference? You just differentiate these two. So this is this. Now, the important thing you can notice is at O, we are not seeing that both are traveling the same optical length. One is traveling more than other. So definitely this won't be central maxima. This is not going to be our central maximum. Very first thing. So where will be our central maximum? Central maxima is the point where what? Where path difference because of these two lights will be 0. So first one is traveling more and second one is traveling less here, if you can see. Done. So done. So that is traveling how much more? Mu minus 1 into T. So to balance it, what we can do, we can make second light travel more geometrically, and first light travel less geometrically. Then this difference can be accommodated, right? So my central maxima will shift where? Up or down? Our central maxima will shift up. So just remember in your head, in whichever directions you are inserting the slit, in that direction only central maxima will shift. Now some questions are also asked like if it will shift by how much, how many central maxima, how many fringes will shift because of this slit. So simply equate this extra difference to n lambda. That n will give you the number of fringes that is getting shifted. Again, you must have studied this in your G-Means. Then what if this slit is in both the directions of light? So we will be simply finding the optical length for both. We will be calculating path difference. So that path difference is coming as this. So if mu1 t is greater than mu2 t, that is if mu1 is greater than mu2, central maxima will shift up. If mu1 is less than mu2, what central maxima will shift down. So that is going to happen, right? Done. Now this is your two waves I have taken. Again, a little bit of thing I still need to discuss. Let's do it fast. So here you can see one wave is emanating from here, releasing from here, second from here, and they both are reaching somewhere at P. So one second is traveling more distance than one. So there is path length between these two waves. Done. And because of these two path lengths, this path length will decide if the wave at P will interfere constructively, destructively, or somewhere in between. Then, now one important thing I want to discuss here is how you can calculate this path length or convert this path length into phase difference, angle difference. So you must have studied if lambda is the path length, then this will correspond to angle of 2 pi radian. Then, so if unit is the path length, then angle will be this much. And if delta is the path length, then angle will be how much? This. So you can calculate path difference into angle difference. This is what I wanted to say. This is your wave number, right? Now we can like what sense I want to give you one more thing, that is if you are writing the equation of first wave, suppose as y1 as a sine omega t. Then suppose amplitude of both waves are different. So a2 sine omega t plus phi. That is your phase difference. That we can calculate from here. This will be our phi. Done. Now, if we have to calculate the net amplitude here, if in questions comes like this, calculate the net amplitude at point T. How you will be solving that? Again, in test discussion, I have done that. I have told you two waves are given and you have to calculate their net amplitude. Treat them like a wave, and length of vectors should be taken as their amplitude, and their phase difference, its phase is omega t, its phase is omega t plus phi, phase difference is phi, write it here, and whatever vector addition you are getting, that will be the net amplitude. So net amplitude will be how much? A1 square plus A2 square plus plus 2 A1 A2 cos phi root over. Then, so this thing I've already discussed. Now intensity of wave. So intensity of wave depends on what you already must have studied. I is directly proportional to amplitude ka square. Done. So I can be written as Ka square. This is your intensity wala formula. Now if there are two waves, suppose in the previous case only we have seen that there were two waves. One was A1 sine omega 2, another was A2 sine omega 2. And if we have to calculate their intensity, now how I will be calculating their intensity? Again, treat them again like the same way we have calculated the amplitude. So, sorry, not like amplitude. So, just calculate the amplitude. How we have calculated the amplitude in previous section. So, A net was how much? A1 square plus A2 square plus 2A1 A2 cos phi, right? So A net ka square. If I'm going to multiply all sides with K, what I will be getting? K A net ka square will become net intensity, and that will be equal to I1 plus I2 plus 2 root I1 root I2 cos phi. So this is how we write the intensity of two waves. If their individual intensities are if intensity of this wave was I1, intensity of this wave is I2, and if angle between them is phi, if phase difference is phi, then I net can be written as I1 plus I2 plus 2 root I1 I2 cos phi, or it can be written as how much? Only as this only, but if maximum intensity we are going to find, for that cos phi will become 1, and this will become as root I1 plus root I2 ka square. And minimum intensity, you already have studied this thing, root I1 minus root I2. Okay. Chalo. Now one just slight thing I want to say here, ki intensity of light depends on slit width. If in the question in YDSC it is given that the slit width of this and this are equal, it means same amount of light will come. So same intensity of light is entering the both slits. But if it is given that their diameter is in 2:1 ratio, suppose this it is double of this one. So intensity ratio will also become 2:1. Done. So larger the aperture, more the light will enter. If in your room large window is there, more light will come, more intensity. Done. So whatever is the ratio of the diameter of this slit, the same will be the ratio of intensity coming from two slits. Done. You need to be careful about that. Chalo, done. Now this is the question again. I discussed theory part of YDSC experiment only, and rest theory things we will be taking up with the question only. Okay. So chalo. First question is there on your screen. I'm giving you again 3 minutes of time. Take your time and do it. ठीक है? You can take 1 minute of break. बहुत हो गया ना? चलो ठीक है. थोड़ा break लेते हैं. 1 minute of break. क्या करोगे इस break में? Just relax. Take some water. अच्छा फेस वॉश कर रहे हो? That is nice now. That gives a nice feeling. Just sprinkling lots of water over face. That makes us feel like we are back to morning. Chalo, good practice. Water is always a magical thing, no? मैं तो बस इधर इधर कर रही हूँ, nothing else. चलो ठीक है, अब रेस्ट हो गया, अब अटेंशन में आते हैं. So come to the attention. Start doing question. I still am in rest. Okay, so this is the question. I need to just, oh sorry, I forgot. Just draw this diagram on your copy. Okay, read the question and draw this diagram on your copy. Then I will move to the question. Now, this is paragraph kind of question. कोई कुछ बोल भी नहीं रहा. Everyone is silently just looking at the question. Now you can't speak. Now you need to ask me to speak. You can raise your hand when you want to speak. It's not like I've taken away your freedom. I've just made it more disciplined, nothing else. Chalo, I hope you all must have drawn it till now. Also, don't forget to point out the points A, B, C, D, E, F, G, H. Point that properly. Okay? Everyone done with the diagram? Done. Chalo, these are your questions. Done. So 3 questions are there. One by one you solve and let me know the answers. Then for first question, again, I have given you some 4 minutes of time. After 4 minutes, I will be checking up all the answers. If you have got one option, like answer option for one, question number 1, then also you can send me. Yes, Pravit. Pravit, check with option of third question. Yes. Reserve. Yes. First is okay. And third one, okay, for third one, you have given me the option. No, you need to consider that as well. Medium 2 was second one, no? Yes. So you need to check with that. Yes, BK. Pravit, you check with the
मैम वेव्स डेंसर से रेयर में जा रही है, रेयर से डेंसर में जा रही है.
आप देख लो कैसे जा रहा है. That's the question ना. Wave can travel from rarer to denser, also from denser to rare. But by looking at the wavefront, what you can observe here, that you have to find out. Still some 40 seconds. Look at things carefully. Yes, soon. चलो ठीक है. Let me go to the diagram first. So here you can see the wavefront. What is wavefront? Wavefront is a surface of constant phase. Yani ki whatever light is here, or here, all are having the same phase. So phase of A is equal to phase of B. Then phase of A is equal to phase of B. First from the basic definition. Also phase of E is equal to phase of F. And similarly, phase of C will be equal to phase of D, something kind of that. Phase of G will be equal to phase of G, H. Because wavefront is what? It is a surface of constant phase. Done. That's okay. Now, second thing, if wavefront is given, how we calculate the direction of light. So direction of light used to be perpendicular to the wavefront. We have studied that if light is traveling in a straight line like this, then wavefront is something like this, because angle between direction of light and wavefront used to be 90 degrees. Just say if my light is suppose converging at certain point. So if my light is converging at certain point, and if I am asked to draw the wavefront, how I will draw that? I will draw the wavefront in such a way that it is becoming perpendicular to this. What surface will look perpendicular to it? If you will draw that, so it will be something like this. Again, its center must be directed towards this convergent point. We can't draw the sphere like this here, like this. Its center must be towards this. Done. So for this, now if the rays are diverging, if rays are diverging like this, then our wavefront will look something like what? We will be drawing again this to perpendicular to this FA, something kind of this. Done. So for both converging and diverging diverging lights, our wavefront will be a part of sphere, right? So these things, keeping these two things in mind, we need to solve all these three things. Light travels as a parallel beam in each media. Now here the wavefront is planar. So if wavefront is planar, it means our light must be traveling in straight lines. Done. So in first case, parallel beam in each media, that is true. Convergent beam, no. Divergent beam, no, because our wavefront is what? Planar. So the option A will be correct for first case. Second case, phase of light waves at C, D, E, F are phi C, phi D, phi E, phi F, and this. So phi C can't be equal to phi D. It is written. Phi C can't be equal to phi D. It is equal actually, because both points are on the same wavefront. Now phi D can't be equal to phi E, D and E. So D and E, phi D can't be equal to phi E. Both are on the same different wavefront, so they can't be what? They can't be your equal. Then, so phi D can be equal to phi E. It is written. So it can't be equal. No? They are different on different wavefronts. So this option is also wrong. Phi D minus phi F is equal to phi C minus phi E. Just see the diagram now. Speed of light, now you have to consider that. Suppose my thing is, suppose I'm assuming this is media N1, this is N2, and N2 is greater than N1. So what will happen to the light coming? Light is this, and it will bend towards the normal. Then wavefront draw kar lo. So its wavefront will look something like this. Done. Now what's happening? Suppose now second case, suppose light is coming like this and it is going away from the normal. So light will go something like this. Incoming wavefront will be this, and outgoing wavefront will be this. Then now in our case, which wavefront is given in the second media? This one or this one? You just see now. This one now. Because if light is going away from the normal, our wavefront will look something like this. Done. So correct option for third will be what? Larger in media 2 than in medium 1. Done. So correct option will be C. Clear hai? Everyone done with this question? We will move ahead, please fast. Chalo. No means yes. Now I have changed the funda. Read the question carefully again. Take some 4 minutes of time I am giving. Read the question carefully and let me know. Most of the questions comes from YDAC. Okay, Rishabh. Third one I said na ki if it is said that the speed of light is, so by looking at the wavefront, you have to answer if light is traveling from rarer to denser or denser to rarer. So what I did for that case, na, I just took the example of both the cases. If my light is traveling, suppose from denser to rare, suppose my light is traveling from denser to rarer. So my incident light is something like this, and this is rarer media, suppose, and this is my denser. So if light is traveling from rarer to denser, it will bend towards the normal. Then now draw the wavefront. I'm just moving in the opposite way. Draw the wavefront. So its wavefront will be something like this. And this wavefront means perpendicular to the direction of light. So it will look something like this. आप मैच करो दोनों डायग्राम को. It is matching, है ना? चलो ठीक है. Again, if there is a confusion, we can draw for the second case also. In second case, I'm taking, suppose this is denser and this is rarer. So ray of light incident in denser medium and traveling through rarer. So denser to rarer, it will go away from the normal. Again, light will travel something like this away from the normal. Now you draw what? Now you draw the wavefront on this. So if properly I have not drawn the, means my ray diagram is not exactly straight. So if you're going to exactly draw it now, it will look something like this. Done. So matlab, in first case, like if light is coming like this and it is, again, I am not able to draw it perfectly, but you can see the difference or not. Like if light is bending towards the normal, my wavefront will be more like this. Take a second, I just got something. Done. Clear hai? Rishabh, you got it or not? You got it or not? Acha, slope you're talking about. So again, you can go with the diagram actually. So what is happening here? If you draw the diagram here, so you need to see with the, okay, you didn't get, okay, done. So what is happening now? Just say if this is the wavefront, this is the wavefront, right? So this is your incident angle. Again, you can go with the angle also. If this is the incident angle, so you can see what angle this is making. You know, that angle you can check clearly. You can or you know, you cannot. You can, right? So if this angle is theta, so this angle will become again 90 minus theta. This is 90 degrees, so this will become theta. So this is making an angle how much? Theta. Again, from this also, directly from the diagram also, if we are correctly drawing, we can see. But if you're not getting, you can see this is making an angle theta. This angle is incidence angle, right? Now come to the angle of this, angle of refraction. So if this angle is theta, this will become how much? This will become your 90 minus theta. Similarly, you can calculate this angle. Calculate now. So you just see what angle it is making. Done. So you will just see it here, and this will make certain this kind of angle. So you just see if the light is, if light is bending towards the normal, what will be the status of this angle? Again, if this is bending towards the normal, definitely R will be what? Less than I, no? R will be less than I. Done. So if R is less than I, so this angle will also be what? Less. Are you getting me? So if this angle is more, this angle will be less. Okay. Got it or not? Just geometry thing, yeah, you need to deal with the geometry. कोई तो और no बोला था. Who was that? Rishabh. So I'm bad at geometry, drawing things perfectly. Weak, some weak. Okay. Chalo ठीक है. But I prefer to go by diagram just anyway. So yeah, do this question. Take your time and do it. If having any doubt, you can ask me. I'm here only.
मैम इसमें मल्टीपल करेक्ट है।
आप देखो चॉइस के बाद एस लिखा हुआ है ना, चॉइसेस, चूज द करेक्ट चॉइस और एस भी है, डन। सो मल्टीपल का करेक्ट, यस। आराम से करो। Okay, I'm checking. Pravit. Okay, done. Yes. Pravit, that will be true. So, okay, check with A once more. Okay, okay, no, no. That is A is okay, B is okay. Check with C. Check with C. Yes, Nimesh. Correct. Chalo, very good. So many of you are getting the things actually. It's very good. Come on, everyone else, come on. Tripti, Risha. Chalo, ठीक है. Let me do it. So you all must have done it almost. Just let's recheck. ठीक है. In Young's double slit experiment, separation between slit is given D, wavelength is lambda. Intensity of light falling on slit S1 is 4 times. Means if I say this is S1 and this is S2, this is a screen, this distance is small d, and here the intensity is 4i and here the intensity is I. This is what the setup looks like. Now we have to choose the options. It depends on like there is a strategy now. I don't remember exactly, but there is key for one correct answer also you will be getting some marks. I don't remember exactly, but there is a guideline you get in every get in exam now every time. Like even if when you are giving the mock test that instruction is there now, so you must read it. Otherwise, I will go through it. I don't remember also. Anyway, so if d equal to lambda, screen will contain only one maxima. Done. So if d equal to lambda, it means what? Just let's see, d sine theta equal to n lambda. It is asking about number of maxima. No? So let's see, put the condition of maxima. nothing is talked about the D and capital D status. So we will assume ki, small d is far, far less than capital D. Theta, sine theta, we will be considering as n lambda by what? N lambda by D. Done. So we will be calculating its value. Done. And if D equal to lambda, D equal to lambda means sine theta will be equal to n, and sine theta maximum value can be what? Only 1. So if I'm taking n equal to 1, then sine theta is 1. Now sine theta is 1, meaning theta is 90 degree. And is theta 90 degree possible to obtain on the screen? You just, I'm going to the another page actually. So I'm not taken, I've forgotten to. So you just see one thing. I'm going to draw that there. Is it possible to get theta equal to 90 degree on the screen? It is not possible. How? You just see here now. This is this. So theta equal to 90 degree means, suppose this is my theta equal to some 60 degree. So as I will keep on increasing this wala thing, angle will keep on increasing. So for theta equal to 90 degree, it seems to meet screen somewhere at infinity. Done. So if this theta is 90 degree, it will not, this line actually won't touch the screen really. Done. So theta equal to 90 degree is not attainable. Yes.
Ma'am, then what for the formula 2d by lambda plus 1 to get the total number of maxima?
Which formula? Condition for maxima.
Yes, ma'am. 2d by lambda plus 1.
Yes. 2d by lambda plus 1. You are talking about minima, I guess. Like, what is the condition for constructive interference condition? Is what? D sine theta equal to N lambda, no? D sine theta is your what? This is your path difference, no? So for constructive interference, that is for maxima, path difference would be N lambda. That is why I've taken here. Yes, what's your doubt?
मैम फिर आपने ये फॉर्मूला किसके लिए बताया था? मैं 2d अपॉन में लैम्डा प्लस आपने बात में टोटल मैक्सिमम नंबर ऑफ मैक्सिमा हमें कितने मिल सकते हैं, तो इसी से तो चेक करूंगा मैं.
Oh my god, what was that? Where you are stuck? I talked about, I just gave you the hint of na, ki how you will be dealing with the question. That was not a formula actually. Where I gave that? I don't remember now. I just told you, yes, this was the numbers now. So n equal to, I just told you ki, what I was discussing at that point. Yes. So I was just giving you a view of ki if you have to calculate number of maximas, then how you will be calculating. So I told you ki maximum value of sine theta can come as 1. So you will be taking this thing. Done. But here also I didn't discuss that case. Ki I told you now in questions I will be picking up more concepts. So I didn't talk about ki theta equal to 90 degree is actually not physically attainable on the screen. That I didn't talk about at that point of time. I was only trying to give you the sense of ki you have, if you have to calculate the number of fringes on the screen, how you will be taking the approach. So you will be simply considering sine theta equal to 1. Again, 2 fringes we will be subtracting from here. Why? Because 90 degrees not attainable on the screen. Again, that I missed out there, but I was just giving you the approach. Sorry if that confused you. Is it okay? Actually, kya hai na, in one day I have to just go through the wave optics, and in one day covering so much of thing is so much like putting burden on my head. I'm just in the hedge key, what to take up, what to not. So it's also putting me in lots of pressure. So I might have escaped, but here in the question again I'm giving that to you, don't worry. So theta equal to 90 degrees not attainable on the screen physically. Done. So even one maxima, first maxima we are not going to get here. So even if first maxima we are not going to get on the both sides, it means only one maxima will be there, and that is your what? central maximum. Done. So if d equal to lambda, the screen will contain only one maximum. Yes, that will be your central maximum. That won't be anything else. Okay? Chalo. If lambda is less than d is less than 2 lambda, then at least one more maximum. Yes. If d equal to not lambda, then definitely, and if d equal to not lambda and d is less than 2 lambda, it means sine theta value will be something less than 1. Done. And if sine theta value is less than 1, that point is attainable on the screen, then definitely one more maxima we will be getting here at least. Done. So B seems like true if 1 is true. Now come to the C. If intensity of light falling on slit 1 is reduced. Now let's talk about the intensity here. In maxima, what happens? Like if both the slit are having same intensity, the formula that you must be using, if according to NCERT, then if both the slits are having same intensity, then the I net formula that we use is how much? 4 I naught cos square phi by 2, where phi is the phase difference at that point because of 2 rays of light. This is the formula you use, I guess. Then, so if intensities are same, then I max will be how much? 4 I naught. And I minimum will be how much? 0. Done. So if intensities are same, dark band will be completely dark and bright band will be your, will carry the intensity of 4 I naught. Okay? That bright band. Now, if intensities are different, then I can give you one sense of key. Suppose this is I1, this is I2. Then at maxima, we will get certain kind of intensity. At minima, the band will be not completely dark because here I1 is not equal to I2. Done. So my I minima, I have given you the formula that is root I1 minus root I2 ka square. So if I1 equal to not I2, then this is not going to be 0. Done. So if the intensity of light falling on slit 1 is reduced so that it becomes equal to that of slit 2. Done. So both are becoming equal. The intensity of observed dark and bright fringes will increase. No. Dark intensity of observed dark fringe will become what? 0. Earlier, when intensities was not equal, that was not 0. Now, since both are becoming equal, intensity of dark fringe will become what? 0. So definitely that is not increasing. Done. So this option is wrong. If the intensity of light falling on slit 2 is increased so that it becomes equal to that of slit 1, the intensity of observed dark and bright fringes will increase. Again, intensity of dark fringe is not going to increase. If both are becoming equal, that will become equal to 0. Okay. So our correct option will be what? A and B. Done. Chalo. Okay. Now let's do this question. Again, be careful in calculation. Calculate it properly. Okay. Take your 3 minutes of time and look at the question carefully and do it. I want to give you here one hint to you, like suppose if our some quantity x is given as a ka power a, b ka power b divided by c ka power c, then we very easily calculate relative error as delta x by x equal to a delta a by a plus b delta b by b plus c delta c by c. This formula you already know. But suppose my quantity it looks like, suppose यहाँ पे जो question दिया हुआ है, what is 2d sin theta equal to lambda, and it is talking about absolute error in d. ठीक है? So d here you can write as what? D here you can write as lambda by 2 sin theta. Done. And here theta is variable. So there is error in theta. How to calculate this error now? Because this is not this simple variable. Done. So how you will do that? Any idea? Anyone? So we can take the help of log actually. We can take the help of log here, take the log both sides. So ln d can be written as what? Ln lambda minus ln 2 sin theta. Now further you can break it, ln lambda minus ln 2 minus ln sin theta. समझ रहे हो? Now you can differentiate both sides and then you will be getting the values. Okay, now do it. So if different kind of variable is there and you have to calculate the error now, you can take help of ln. That is the logic. चलो करो. Every question should be a learning, ठीक है? Learn things properly. Okay. Ravit. Okay, done. What about the fractional error? I don't remember the answer actually, sorry. चलो मैं करती हूँ. So what you are doing, ln d. So if you are going to take its differentiate both sides, what we are going to do, what we are going to get. So differentiation of ln d will be how much? 1 by d delta d will be equal to how much again? This will be, this is a constant now. Lambda is what here? Constant. Wavelength lambda is exactly known. So this is a constant. There is no error in this. So let make it 0. ln 2 also make it 0. Ln sin theta. So this will become sin theta. Jaise, okay, done. Everyone is getting B actually. So let's see now. So 1 by sin theta and how much value you are going to get there also. This will become cos theta del theta. If you are properly going to integrate, जैसे d ln sin theta by क्या लिखोगे आप? d sin theta into क्या लिखोगे? d sin theta by d theta into d theta. Done. So this whole thing you are going to do. So d ln sin 1 by sin theta into cos theta into d theta. That I have written here. So delta d by d, you can see here what we are going to get. We are going to get minus cot theta into del theta. Done. So this value we are going to get. So theta is increasing, right? Absolute error in d remains constant. Absolute error in d, that is delta d. You have to calculate. So delta d value will be how much? First see delta d by d, that is cot theta. So cot theta value will become what? Cot theta value will increase as angle will increase, or will it decrease? As angle increase,
minus sign increase करेगी.
Yes. So since there is a minus sign now, so that will what? That will increase, right? Because as theta increase from 0 to 90, cot theta is going to decrease. There is a minus sign, so it will increase. So that is increasing. Now delta d value you can calculate here, and you can write here minus d cot theta d theta. So minus d can be written as what? If you see carefully, d can be written as again lambda by 2 sin theta. So here you can again write lambda by 2. Am I correct? Lambda by 2, yes, sin theta into cot theta d theta. So if you see here, this will become what? Cos theta by sin square theta. So something in delta d we are getting cos theta by sin square theta. So as theta will increase, this will decrease. Done. And this will what? Increase. So numerator is what? Numerator is decreasing. Denominator is increasing. Overall value will what? Decrease only, right? Done. So similarly, you just needed to you just needed to be wise with the calculation. You needed to calculate the ln wala thing now. So here we needed to be wise ki how to calculate the error. Done. So that is it. So if calculation you are doing correctly, you will be getting the answer. Done. Chalo, we are having less time actually. So I want you to solve this question. Solve it. Take some 3 minutes of your time and do it. Again, we have covered almost in wave optics. You just need to practice more now. Keep updating me the answers. Okay, Pravit, yes. Move to another one, another two, check another two. You just have to see the fringe width now. Formula everyone knows, lambda d by d. Done. So with one you are correct. D you need to check again. Angular separation fringes ka what will be? Lambda by. If you're talking about two consecutive fringes, then it will be what? Lambda by d now. So lambda 1 is less than lambda 2 no? Done. So the first option is asking about what? That is asking about beta is what? Beta is your fringe width. Done. So fringe width we write as what? Fringe width is written as lambda d by d. Done. So lambda 1 d by d. So beta 1 और beta 2 में क्या relation होगा? Beta 1 will be d by d is constant in both now. Lambda 1 is less than lambda 2. Lambda 1 is less than lambda 2. It means beta 1 will be less than beta 2. So beta 2 is greater than beta 1. First is correct. Second is what? Beta 2 and number of fringes for them within a distance y on one side of the central maxima are m1 and m2. So if we are fixing the distance y, then this distance y is fixed and number of fringes for one is m1 in this and for another is how much it is m2. So just see how much angle it is taking. So how much angle it is taking. So d sine theta you will be taking as m lambda. So theta will become equal to how much? M lambda by d. Done. So this is, and this linear distance will be equal to this m lambda d by d. Done. Now you just equate this linear distance for both. That will be same now. So m1 lambda 1 will be equal to m2 lambda 2. Now you just see lambda m1 by m2 is how much? Lambda 2 by lambda 1. That is how much? 600 by 400. So that is something like 3 by 2. So definitely m1 is what? M1 is greater than m2. So second is also what? True. Done. Now from the central maxima, third maxima of lambda 2. Third maxima of lambda 2 मतलब चलो angular separation लिख लेते हैं. Third maxima of lambda 2 का मतलब what will be the angular position? That will be your 3 lambda or 2 by d. overlaps with fifth minima of lambda 1. What will be the angular position of fifth minima of lambda 2? So what is the condition for minima? 2n plus 1 lambda by 2. First minima ke liye I told you take n equal to 0. So for fifth minima we will be taking n equal to 4. So this will become 9 lambda by 2. So angular separation will be 9 lambda by 2 d. And this both are overlapping, means these two angular positions are same. So now, sorry, this is lambda 1 now. So now equate these two and just try to see what you are getting. This is 3. From the central maxima, third maxima, okay, we needed to check actually if they are equal or not. Oh my God. So just try doing that. Okay. I'm also out of my sense, I guess. No. Chalo, okay. So what I did, central maxima, third maxima of lambda 2 means just check if it is getting equal or not. 3 into lambda 2. Lambda 2 is how much? That is your 600 divided by d. And what is the fifth minima of lambda 1? That is 9 lambda. That is 400 by 2d. So both are same now. 1800 by d, 1800 by d. So this is also correct. Now the angular separation of fringes of lambda 1 is greater than lambda 2. Angular separation means lambda by d. Done. So lambda by d will be greater for what? For what? Whose wavelength will be greater? Their angular separation will also be greater. So angular separation of fringes of lambda 1 is greater? No, because lambda 1 is less than lambda 2 here. So this is wrong. Correct answer is ABC. Okay. I hope it is done. This was a question actually. These two questions I needed to discuss more. So that I will be doing tomorrow. These two questions. Here we need to use that wala logic, fringes, shape and all. So again, I will suggest you ki just open books and do solve previous year questions more and more, and try more. Done. And in tomorrow class, I have to start with mechanics. So I will be dealing with what is that, your unit and dimension 1D and 2D. So we will be collecting questions from that portion. We'll be doing there only. Done. And from wave optics, I will be picking some more 2 questions. Then Malice's law and Polaroid, you already know. You all must have studied in your G-mains wala thing. You have got enough marks now. You must be knowing all those things. I don't need to waste my time there. So 2 questions I will be picking more from the wave optics. After that, we will be jumping into what? Mechanics. Okay. Work energy se start karu. Why I'm that I can also focus on, but actually planning is made. I need to move according to that also. And if I move, like questions you will be getting from your 1D, 2D, and from what is that? Unit and dimension also now from instruments. So in 1D only I will do. Next day we will be moving on to the next thing. Done. So nothing to worry about. But yes, please do come after reading your instrument. That is your what things? Screw gauge and your vernier calipers. Done. Have a little bit look over that. Done. Chalo, take it. Bye bye. Take care. Stay safe. Stay healthy. Keep enjoying and don't take tension. Take it. Only work. That is only in your hand. Bye bye. Thank you, Tripti. Stay focused. Thank you so much. Thank you. It's getting tough for me also, tough for you also. Chalo, dono hi tough enjoy karte hain. Bye bye. Oh my God, why I'm not